So this is going to be a Unity 2D Tools presentation, and it's live and hands-on with Dragon Crashers. Specifically, I'm going to be focusing on the 2D tool workflows, the new workflows that we've been adding to Unity and improving over the last number of years. These workflows range from everything from sprite rigging to importing assets to lighting to animation, and this demo is going to cover a wide range of different workflows shown in context. If you're not interested in 2D tools, the demo is also going to cover maybe a couple of other areas that you might be interested in, such as timeline and things like that. But mostly it's a 2D tools presentation. My name is Andy Touch. I'm a senior content developer at Unity. I joined Unity almost 8 years ago. And I build all kinds of demos and basically teach and show people how to use Unity and give a lot of feedback to R&D directly. I was heavily involved with developing this project called Dragon Crashers, which I'm going to use as an example, along with Jarek or Mindjar Design, who's also in the chat. And Eduardo and pretty much all the panelists as well. And I'm very happy to have the project finished and released, and now we can then teach you and show you the workflows that we use to create it and how you could use those in your own projects. So this is basically what I'm going to be showing directly inside the editor. So I'm going to show a lot of different workflows, but rather than listing a series of features like PSD importer or sprite editor and things like this, I'd rather show this the workflows of these features based on context. So I'm going to be going through the process of exporting a 2D character from Photoshop into Unity, setting up that character's sprite rig, setting up IK or inverse kinematics for characters' limbs, using sprite swapping for different, I wrote different character limb visuals, it's supposed to be different character limb visuals, using 2D lighting to illuminate your sprite art, so taking it from unlit to to having like things like normal maps or things like different glows and details, and then also applying those secondary textures like normal maps and mask maps for extra 2D lighting styles. And then lastly, sequencing character animations using timeline. So that's basically what this presentation is going to be about. If there's other 2D topics or other Unity topics in general that doesn't fit that kind of like those elements that you might be interested in, you can fill in the survey afterwards or post it in the chat or post on the forums and we'll read it and we'll see if we can set up a webinar in the future to cover those kinds of workflows. So to demonstrate all these different features, I'm going to be using a recently released project called Dragon Crashers. This is a new project from Unity focused on 2D tools and workflows. And it's been created to be a vertical slice of an idle RPG project, where you have a series of characters, both heroes and villains, who fight each other through automatic attacks and also manual special abilities. In this project, we probably use about 90% of 2D features in Unity's 2D toolset, all the ones that made sense to use in this project. And it touches from everything from like environment building to character rigging animation to particles to custom shaders and pretty much a little bit everything in between. As well as 2D tools, we also focused on things like UI and also audio. So we try to build a demo that's not just focusing on 2D tools, but also other areas that might hook into it, such as using the particle system to create particles around the 2D sprites and things like this. So if you're not familiar with 2D tools and you're making a 3D game, you can still learn from this project if you want to look at other areas such as UI or even code structure. So I'm going to be using this project for this demo. So I'm going to finish my slides and I'm going to jump over to Unity. So I have the project already here, and this is a battle between these three heroes, the witch, the knight, and the wolfman. And I'll hide this, and the dragon here. Now, if I click play, we can then see the intro cutscene and the battle gameplay. So that's pretty much the gameplay of Dragon Crashers. It's a idle RPG. You have a series of units that auto attack each other for kind of lower damage. And then when their cooldown bar charges for their special ability, you can then activate it and they do an attack that has different types of VFX and different types of damage. And in this project, we created it to be generally modular, so we can take the characters, we can take all the different elements or the prefabs and then reconstruct them into different types of battles or different types of scenarios. Now for this demo, I'm going to specifically focus on this witch. So you have this witch character here, and the witch character is interesting because she has a lot of different elements that I'm going to dissect. So everything from like the light from the staff to her normal maps, to the Fresnel, to her rig, and all these different elements. So I'm going to go through that process of actually creating and building up this character, and pretty much the exact same workflow that we did ourselves when building this project. So the journey is going to start actually not in Unity, but it's actually going to start in Photoshop. So I have here this witch character in Photoshop, and you can see that she's standing at a pretty straight pose. She's built up of individual layers, so I can actually turn off like all the different parts like her arms and all different things. They're kept as separate pieces. And she's standing not in like a T pose, not in any other pose. She's built up all these layers and she's already been painted by a wonderful artist called Yarrick, or Mindjar Design. And what we want to do is we want to export this witch directly into Unity in a way that a lot of this data can be preserved and carried across. For example, we might want to bring in the witch, but then we want to animate her, or maybe change her armor to be something different, or maybe we want to apply shaders to her hair and things like this. We want to keep each of these individual layers accessible. So Unity has a PSD importer which you can use, and you can install that through the package manager that carries a lot of this data over. So I go to File, Save As, I give it an appropriate name, in this case character witch, seems like a pretty good name. And I can save it as a different type format, as you can typically do in these tools. I'm going to save it as a PSB file, which basically stands for Photoshop Big, or a large document format. What this is going to do is it's going to be picked up by Unity when it's imported, and it's going to carry over those elements such as layers and order and things like that automatically. You don't have to then go do the boring task of re-Frankensteining it on the other end. So with that set, I'm going to click Save, click OK on this panel like pretty much everyone does, and then I'm going to go back into Unity. I'll do basically like 1 or 2 seconds loading. What you'll notice is we now have this character here imported. We have the character here in Unity. I mean, this is nothing too exciting. Unity's been able to import assets for well over a decade. But the interesting thing here is because it's a PSB file, it's brought in extra data, such as do we want to use a character rig? It's a multiple set of sprites. We also have options for use layer grouping. And if I bring the character into the scene, notice that she's basically already set up identical as she looked in Photoshop, with the position of everything and all of her individual limbs. Now, if I expand that Photoshop file of the witch, you'll notice that we have each of the different pieces as a child game object, such as her mouth and her leg and things like this. We also have all the individual sprites. It's automatically picked up all of those layers and it's auto sliced them into individual pieces. So it means that we don't have to go through that boring process of chopping everything up. Unity's just done that automatically for each individual layer. Now, if I select the witch asset, what I want to do is I want to add a sprite rig or some kind of structure that allows us to animate the witch or pose her in different ways. So what I'm going to do is I'm going to select the witch and open up the sprite editor. And the sprite editor is kind of like a middle tool that allows you to take your assets when you import them for 2D UI and then manipulate them before you then add them to your game. Kind of the metaphor I use, it's kind of like your chopping board to prepare your vegetables before they go in the soup. So usually if you're making carrot soup, you usually get your carrots, right? And you get them prepared. And then you prepare them by peeling them, chopping them, mushing them, preparing them in that way before you put it into the pot. So this is kind of that area where you prepare your assets and in this case sprites before you then bring it into your game. As you can see here, we already have the witch split up into many different pieces, again kind of been like Frankenstein. And this is done automatic through that sprite editor, that sprite asset process. Now the sprite editor allows us to not only slice up sprites, but it also allows us to do many other cool things with sprites, such as setting up a custom physics shape or applying a custom outline. But for this demo, I specifically want to set up the skinning editor for the witch's rig. So I'm going to switch over to this view. And notice how it changes the context. We have these different views for their different purposes and tools. So with the skinning editor enabled, notice that the witch is basically kind of like reformed back into what her Photoshop file looks like. And what the Photoshop file does is it allows you to what this skinning editor does is it allows you to now set up a rig of some kind and basically bind it to this character asset. You can do this through creating bones, creating geometry, but also setting up weights. So if I select create bone, notice here that we've got this like little bone marker here. And we can then set up some kind of structure. So I'm going to set up a pretty standard structure for a humanoid character. So I'm going to start with her hips, which is the usual root point of a rig, her spine. Notice you can just click, set up the neck, the head, and let's do the tip of the hat. And then if I right click, it basically confirms that this is kind of like one set of a bone structure. I'm then going to set up her back arm. So I'm going to click here from her neck. And notice it's now creating new bones along this area here, and let's do from her neck down this limb here. And last but not least, I'm going to set up her legs. Obviously I'm doing this very quick because I don't have a ton of time, but hopefully you should be able to see roughly like, you know, how you use this tool. You just click, and then you can set up this whole structure pretty much in seconds. Obviously, if you're like setting up more complex characters or more complex forms, or you want more bones in the hat and stuff like this, you spend a lot more time. But hopefully, you get the idea of how this like sprite editor tool works. So now with these bones all assigned into this asset or this file, we then need to assign these bones to the geometry. And we can do this in a couple of ways. We could either do this like the really long and laborious way, which is to create individual vertices and click all the way around. But unfortunately, this webinar is not like 5 hours long, and people get pretty bored of me doing that. And I'm a big fan of letting computers do what they do best, which is processing and automating a lot of boring tasks. If there's a task that like you have to do 20 times, I'd rather have the computer, which is already pretty smart, like, you know, auto do all this stuff for you. So I'm going to cheat. Well, not cheat. I'm just going to use the tools provided and use this auto geometry tool, which basically is going to do all that process for me. So I'm just going to click this generate for all visible, use the default settings. And within like a couple of seconds, it's automatically created a shape around each of the individual sprites and assigned the bones to it, which is pretty cool. I can toggle this little sprite sheet option, so I can actually view each of the individual layers to see like what the geometry looks like. Like maybe I think the cape hasn't got enough detail, and then I want to like, you know, add extra points to it and edit it. Or maybe I feel like the leg is too heavy. So you can then like auto generate and do like 90% of your work or something, and then you can then go in and like tidy up and remove different elements and polish it up a little bit more. And luckily with this project, you can download and look at the characters already prepared and created by Jarek, so you can see how he's set up these characteristics, because he obviously had a lot more time than my 10-minute slot and stuff like this. So let's put it back together. And notice that we got these rigs, the bones, and we got the geometry already in a matter of seconds. So now we need to see how these bones are actually influencing on the body parts. So let's have a look at the arm. So I can actually move these bones and actually see what the influence looks like. And notice that as we move this arm here, the cape is kind of like getting pulled with it. And maybe that's not what we wanted. The automatic geometry baking process is basically just going to go in and try and work its way out as best as it can. And I actually left this issue or this outcome in here purposely to basically show you how you can kind of fix this. I knew it was going to do this. So and the reason why it's doing it kind of makes sense, which is basically that you can take each individual layer and when it's applying that geometry and the weights data, imagine all the layers are on top of each other, right? So it's basically just applying it all the way down. And this is where the extra tools come in use, because then you can kind of like tidy up and like repaint a couple of different areas and, just tidy up different things. So if I now move this arm back here, and if I click this bone influence option, I can click a particular piece of the character or a particular layer. We can actually see all the bones in this little list that are actually affecting this particular part, and I can actually remove them. So if I remove, actually I want to remove this one here. Notice it then pops back. I want to remove this one here. Notice that the cape is now actually normal. If I select this one, okay, it's popped back. So now when I move the arm, it's actually okay. And I've noticed a little bit here, so let's do that. Let's remove the bone influence here. So now I've been able to like fix the arm and it's all working okay. So even though we've got this witch character, which has many different layers, we basically got this all fixed for the arm. So I'm now going to do it for the other arm. We've got a similar issue. Remove those bones. Move that bit because that bit's not wanted. Very exciting stuff. I remember trying to do stuff like this in Flash like 10 years ago, and it's a huge pain in the butt, and now it's all already here. I wish I had a time machine to go back in time and tell previous Andy, hey, don't worry about this. All this stuff will be fixed by Unity in the future. Remove that. Obviously this leg is now like massively pulled here. Now I could have chosen a much simpler character that didn't have all these like overlapping parts, but I consciously did it just to show you, like issues that could possibly happen. So if you run across this sort of like issue in your own workflows and stuff, you can think back to when you're like, oh yeah, I remember Andy told me about this stuff. I should probably go in and check out the bone structure and make sure it isn't auto-painted to different areas. And one last bit, which is this one here, and I think she's done pretty much. All her limbs are done, right? So I can move all the legs and that all works. There we go. Now got a potential run pose, right? So now we've got our legs all fixed. Now that's just assigning the bone influence. In a couple of instances, maybe we want to paint and manually manipulate how a sprite bends kind of like internally. So notice here that we've got this light blue line, light blue bone, and we've got this dark blue bone. And the colors here of the hat are basically showing what's the influence of the bone area. So if I move the hat like this, notice that this hat is staying like this part of the hat is staying pretty stationary, whereas this part on here is like kind of like snapping and bending. So we need to basically change that influence. So what I'm going to do is I'm going to select the bone here, open up that weight brush, and I can then select the bone and I can then paint. So if I now bend this back, I can actually paint this back into position, and notice it like reshuffles. So now I can move this hat here. I can repaint. So I've now got the top of the hat bending. Let's go here. Repaint that in. It's actually pretty fun to do this. If you're 3D modeling, you've probably already done something like this in like Maya or any other number of 3D modeling tools. Notice that this part of the hat moves. And obviously, if we were to do things like hat moves in the wind or the hair moves in the wind, we could add extra bones and paint other influences. But I think for the purposes of this demo, it actually comes out nice. So I've basically shown you like the bone influences for the limbs, but then also actually painting and manipulating, one particular bone part. So I'm pretty happy with how this looks. So what I'm going to do is I'm going to click apply. And then what it's going to do is, almost as if by magic, our character here, if I select her now in our scene, because notice she's like in our scene, those bones have automatically come through when I hit apply. Like, look at this, I can now do all that bending directly in the scene. I can actually move all these limbs and notice they're all moving independently. So now all that setup that I did in that sprite editor interface is now all applied directly into the game object that's in our scene. It's like pretty instantaneous. I can obviously go back and tidy things up a little bit and maybe add some more bones in her arms or whatever, or maybe I want to rig her hair and things. But this is it's a pretty slick workflow to just go in and say, oh, I've now got all these bones assigned. One thing you might notice is that the bones here are all transforms. So the transforms all line up to certain points of the sprite. And as they're transforms, or they're just game objects with transforms, you can now do things like attach a light onto like the end of her hand, or maybe she has like a glowing hat, or maybe particles spawn from like her shoes when she runs. So you can see that basically you can attach different components and can attach different parts to your rig. So these aren't just like a kind of a concealed rig. You can now actually add nested elements to your rigged asset or rigged character. There's one thing some of you have probably noticed and probably mentioned in the chat, and that's basically that her face kind of looks a bit weird. She's got like this closed eye here, but then her mouth is kind of freaky. She's got like this open mouth, but then this like weird, almost like half Joker smile in the background. And that's partly because she's got a lot of sprites which are basically stacked on top of each other into a different place. A lot of sprites stacked on top of the same place. So if I now cut back to Photoshop and zoom in, what you'll notice is that we've basically got here this mouth, and if I open up that folder here, if I turn off all of the mouth layers, you'll notice that basically she kind of looks like Neo from the Matrix when he's being interrogated. But if I then enable each of the layers, you can see that we've got the mouth open, we've got like the mouth teeth, we've got the mouth normal, and basically we have each of these layers for different types of face expressions. And what we probably want to do in our games, if we have like a cutscene or we want our character to have a different face pose, is import in these sprites and then like swap between them when basically something happens. Like maybe in the code you want to change to like a happy character, or maybe when you animate it changes to like an angry character and things. Also, like to take this further, maybe you want to change like a hat or like gloves, or maybe her hair to like a different type of hair when something happens. So we're going to use a thing called sprite swap, which allows us to swap these different sprites out automatically. Now remember, when I exported this asset, it brings in all of these individual layers. So now if I jump into Unity and I go back to our good friend the sprite editor, and I go back to the skinning editor, if I enable this little visibility panel in the top right, notice that we have a hierarchy in here to view our total rig setup and all these different layers from Photoshop. So now if I open up the mouth and the eyes and all these different things, we've got mouth open, mouth teeth, mouth normal. What I can do is I can set up a category for these particular assets. So I can set up let's set up a mouth category. So all of these, like mouth open, mouth angry and stuff, are all connected to mouth. Let's look at the eye. So IL, and we've got a left eye now because we want it to be open and closed. Let's set up the eye right as well. Obviously we could go in and we could set up like different types of hats or different types of clothing and things like this. But now that these categories are sorted, check out this. So when you click apply, okay, within a second, let's go back to our character. Oh look, the weird Joker smile is no longer there. And if I now select her mouth, I can now swap automatically between the different categories. So now I don't have to program like a system to say, hey look, swap to this sprite, swap to this sprite. I mean, I might have to do it if you're adding this to extra gameplay, but now you can swap out these different sprites assets automatically, and it just does it automatically when you set up those categories. So for Dragon Crashers, we use this for different types of face expressions for characters when they do attacks, and I'll show you this a little bit later on. So yeah, we've now got a rig set up and we've got different face poses. I'm going to give her let's give her a happy face. So the next thing that I'm going to show you before I kind of move on to things like lighting is IK. So now that we've got all of our bones for all of our arms and all of our pieces, maybe we want to animate her. Maybe we want her to like lift up a staff and then cast some magic on something. Now, if we were to create that animation, we'd have to like move this arm and then keyframe that, and move this part, keyframe that, and move this part. And that takes a lot of time. I mean, for lifting a staff, it's actually probably pretty quick. And for the artist who created this, he could probably do that with his eyes closed. But if you wanted to create something like an idle animation or a running animation and things, those things take a lot of time if you're doing it in that way. So this is where inverse kinematics come in, or IK for short. And what inverse kinematics do is they allow you to set up like target points, which you can then hook onto parts of a series of bones in a rig. And then it allows you to move a lot of bones or control a lot of that rig data by just moving that target. So in the case of a limb, like an arm, you've got like a shoulder, an elbow, and like a wrist, right? So you want to move the wrist, and then all your shoulder and elbow moves automatically. You don't want to move all those individual pieces. And that's where IK comes in great use. So as part of Unity's 2D offering, we've got an IK manager. We can set up all these different limbs. Limb-based, all these different IKs, both limb-based, but also like chain-based, which I'll show you a little bit later on. So I'm just going to set one up for our back arm. So we've got this IK manager here. And we also have this limb solver. The limb solver needs two things. One, which is a target, which is just a transform. So this is actually the target here. It's actually currently invisible, so that's okay. And the other one is actually the effector, like what bone does it affect or what object does it affect. So if I now open up the character and go to her bone structure, because remember I said all these are transforms, I can then assign her bone for a hand to that IK limb solver. And now what you'll notice is that as I move that target around, which is this like circle, and notice these like green lines appear, I can now move this character's arm, and all I need to do is move this target, and it's automatically going to take the shoulder, take the elbow, and take all these different parts, and it's going to move automatically. So if I wanted to animate this character, like, you know, doing a punch, I could just take this target and then animate this punch happening, or maybe I want to do it via code or something like this. So there's now an IK manager for 2D, and it works seamlessly with the 2D rigging system. Excellent. So now that we have that in place, and we've got this IK like this, obviously I'm skimming over a lot of topics. Like IK is obviously a significantly larger topic than what I'm covering, and obviously elements like rigging are significantly bigger, but I just wanted to show kind of like a couple of key areas, and then you can dive in to a little bit more detail either in this project or with other resources about these different areas. So we've got this hand here, and what I want to do is I want to put a staff into the hand. So I've got this staff here which has this like this swirling effect and this sprite, and it's actually got a light on the end which you can't quite see yet. So I'm going to, as this is a prefab, I'm just going to nest this to the hand bone and like put it here. So it's now like in her hand. I was going to make a Gandalf joke, but I won't bother. So now she's basically got like this staff or this weapon nested as a child prefab to her hand. So notice I can move this target, and then the staff is going to move. So I can now do you shall not pass or whatever, and I could have her raise her staff and then cast some magic and things like this. So I've got this staff here. This stuff is going to come in use because basically the staff has a light on the end of it, but you can't quite see it. And I'm sure some people so far have said, the witch looks kind of weird. She looks very flat compared to the artwork in the environment. Like she doesn't really belong yet. And that is true. Like as you can see here on this lamppost, the lamppost has got lighting coming from this lamp. It's also got like a Fresnel, like this blue outline here. And the witch is kind of very flat and doesn't fit into that kind of lighting setup. And that's because Unity now has a 2D lighting system which you can use to point at different types of 2D sorting layers. If I actually turn off the 2D lighting, notice how much different everything looks, especially this lamppost. So this is the lamppost asset without any 2D lighting applied to it. This is what it just looks like prior to Unity 2D lights. Turning it on, look how much more impactful it is. And the other really cool thing is that I can actually take this lantern, and if I actually move it around, notice that the lamppost actually adapts. So it actually looks kind of 3D because this lantern is actually moving around and it's influencing the normal maps and all the different elements of the sprite. And if I now go to this staff, what you'll notice is that there's a 2D light at the end of the staff which I can move around the scene as well. So this staff is actually working. It's actually like lighting up different elements in the scene. But what you might notice is that it's not affecting the witch at all. Now if I have a look at the staff, let's see what kind of properties we have. So you can adjust on this 2D light, which is like a 2D point light, like the range. You can also adjust the intensity, which is pretty standard. You can turn on and off like the normal map influence. You can even do like a spotlight type thing with like a really soft, smooth fall off and things like this. So with the 2D lights, you can really sculpt and set up different types of styles and formats. And in this demo, we use a lot of 2D point lights, and we also use a lot of other types of lights. So in 2D lights, we use a lot of freeform lights, which are kind of like spline lights, or like freeform shape lights. Sprite lights, which are basically like light cookies. We also have like a global light, which is like a big fill light, and all these different things. So I'm going to put this light back at the end of the staff, and let's see if we can get the witch actually connected and tying to these different light layers. So one thing you might notice is that the light is only affecting this main layer. If I actually look at the light here, what you'll notice is that it can target different 2D sorting layers, in this case the main and the character layer, but it's not actually affecting the background layer. Now if I enable the background layer on here, notice that this blue light is now affecting this background layer, and we get all these really nice normal maps on this background asset. So it's affecting those specific layers. Now if I select the witch, I could go through to each of our limbs and say, okay, you're on the default sorting layer, but I want to put you on the background layer or the main layer, and connect to those lights on that specific layer. But that's going to take a lot of time. And as I said, I'm a big fan of workflows that save a lot of time. So instead, I'm going to use another component called a sorting group. Now, the sorting group is very powerful because it allows you to take all of the child layers and put them on a specific sorting group layer. So in this project, we have a sorting group or sorting layer for all the background sprites. So that's all the stuff like the lava and like this roller coaster and things like this. We also have a main layer, which is like for the ground and like all the assets here, like the rocks and the posts. We also have a layer for the like characters. So we basically add a bunch of fill lights and stuff just to bring out the characters, which is pretty common to like movie techniques where they have lights just for the actors in a scene. We also have foreground, which is basically all like this blurred stuff that you can see like around the edge. We also have one for the UI as well. So I'm going to go and put the witch on the character layer. And what you'll notice is she gets a bit darker, and now the light will actually affect her as she moves around in the scene, which is pretty cool. I can actually put her onto other types of layers. So if I put her onto like the background layer, what you'll notice is that she's actually glows like very red. And that's because we have a bunch of lights here to make it like kind of simulate like the lava and things like this. If I put her on the main layer, then she's going to use like the lighting that's on the main layer, but instead we want on the character layer. So we've now got the witch tied into any lighting on that layer, and it can be used like this. I can now turn on and off the lighting, and you can see that it's basically the witch is now more tied into the lighting of the scene. So we have more light influence here, we have more light influence around from the staff. So if I now open up the staff, have a look at this, and if I move this around, notice that the character is now being lit up by this light. And that's because the character is using the sprite lit shader. As Universal Render Pipeline comes with both sprite unlit and sprite lit shaders, and she's using that sprite lit shader. So all the 2D lighting works with that automatically. So Some other people are probably wondering, okay, that sounds cool, but she's got no normal maps, she's got no Fresnel maps. She still looks kind of a little bit flat compared to the other assets in the scene, and that's true. So now we need to apply onto her some normal maps and secondary textures. I'm going to go back to the sprite editor, our good friend, and basically we've got here in the secondary texture editor a way to add in texture assets for like normal maps and mask maps and all these different things to tie into Unity's 2D lighting system. So kind of like a skinning editor where you would use to like rig characters and things like this, you're using the secondary textures to set up normal maps and mask maps and things like this. So what you can notice here is we've got like the Frankenstein version of this character. I'm going to add a new secondary texture here, and I'm going to add a normal map. Now with the normal map enabled, what you can notice is that if I now assign this, which is a normal map asset, and look at it, you'll notice that basically we've now got a normal map assigned to each of the individual parts of her sprite shape, or her sprite form. So each of her legs and arms and head and things like this have a normal map sprite associated with it. So normal maps are nothing new in games in general. They've been around in the industry for many years before. They just haven't been like a first class or first party workflow or asset in many 2D engine, 2D frameworks and things like that. And what we decided with Unity is to kind of like help level up people's 2D graphics. We decided to bring in these normal map workflows and to work with Unity lights and sprite rigging and all these tools that we're already adding into Unity. So here we've got the normal map already pre-prepared by an amazing artist who basically has already hand painted all the normal map influence for the lighting. Of course, you don't have to hand paint it. You can also use tools like to auto bake normal maps, like maybe like Photoshop, or I think there's one called Pixel Lamp or Lamp Pixel, I can't remember, that you can use to basically take your sprites and bake this, like lighting data. So I'm going to add and this all works with Unity's 2D lights, which I'll show you in a second. Now what I'm going to do is I'm going to add another secondary texture, and this is a mask texture. I'll add the one from the witch that's in the project. Obviously you can download these and inspect them for many hours after this. The mask texture is a bit more simpler than the normal map. So whilst the normal map has these the color data to basically show the different influences of different light directions, what the mask texture does is it allows you to mask or color in certain areas of your sprites. So if you wanted like a glowing Fresnel from a certain point, or like some kind of outline. And we wanted to use Unity's 2D lights in this demo to not only have like a hand-painted feel, but also have things like glowing Fresnel, like from lava or from blue crystals and things like this. So we basically apply a mask texture as well to our sprite asset. So now when I click apply, if I now go back, look, the witch looks like 10 times better. So if I now turn off the 2D lights, she looks very flat. Turn them on, she's now got normal maps applied. And obviously these normal maps and the mask maps were prepared beforehand, but now they're applied to this character. You can still do IK, you can still move different elements. We can actually move the character around the scene. Notice how the light from the lamp is actually affecting her hat in different ways. I can actually grab the light at the end of her staff, and as I move it around the character, notice that there's a lot more depth to her shape and her form. So as you can see here with her hand, as I move the light around the hand, even though I'm moving this light around the sprite, is actually having an influence from its direction because of the normal maps. Ooh, my internet dropped out just quickly, so hopefully back now. So now we've basically got our normal map influence for our character. And I remember the first time I saw this with the assets for when they were imported. Basically, I actually thought they were like 3D assets to begin with. I was too used to seeing like 2D content being very flat. And I was kind of blown away that we can now have normal maps as part of our lighting system and as part of our workflow. The next thing I want to show you is that Fresnel map. So currently there's no like Fresnel influence currently happening. Like she's getting this glow from like the normal map, so I can actually lower down the normal map influence to like 0.1. You can see that we have like the dark side of the hat here. It's a bad Pink Floyd joke. And the dark side here as well. But I showed that mask texture, which had like the white outline around the edge. So basically I can now choose a different like blend style. So like this is like the Fresnel layer on the light. And notice that now this light is now affecting all the Fresnel in the scene. So obviously this is dialed way up. So if I turn this down a little bit, notice that we now have this like blue hard line around this mask texture that this light is then affecting. So obviously we use this a lot for like lava and things. So if I have like a red area, maybe we want like, you know, some red glow from behind the character, we can kind of like fake this by using 2D lights. So we could have a 2D light with like a high Fresnel here, but then basically have like a glow coming from a certain direction of the character. So you get this kind of really nice hand-painted style, especially around the edges of her hair and like her face and her hat here. So it's a really interesting like really interesting results that you can get, which are all like real time, and like the colors of the thing, the colors and the influences are not baked in, just like how the light is actually influencing the just the areas that are actually being influenced by these lights. So yeah, that's kind of like a quick rough overview of 2D lights. And also you can see the light here, so she can come up here and she's actually like lighting up all the background here, and all the lights in the scene. So we use the 2D lights heavily. So if I actually turn off the 2D lights, like look at how different the dragon is. Like this is like unlit, and then with lights, we now have really nice Fresnel around the outside edge of his jaws, but then also we have really nice normal map details. Obviously you can download the project and dissect and learn from it yourself, like how all these things were done. So I'm going to move on to the next thing now, which is animation. We've got a character set up with a staff, and she has a rig, and she has an IK, and she's lit and looks great. So I'm now going to enable this other witch, and this other witch is basically the same witch, but has more IK for like her other arms, like her back arm, also her feet. So if I move her leg in the air and have her kicking or something like this. So it's basically like kind of like a cooking show where I jump forward, you know, past the point where I actually bake the cake. So this is basically the same character. And I wanted to show animation. So using these workflows, Jarek, who's like the artist, he was able to use the IK system and the sprite solver to create all the animations. So if I now select this witch idle animation, we now have this animation of the witch idling, influenced from the IK of her limbs. And notice that the staff is basically carried in her hand. And if I now switch to say like this like running animation, we now have this run animation for this witch as well. So you can see here basically we have this whole rig all authored entirely in Unity from just these workflows that I was showing you of this character running on the spot. And we also have like a witch attack as well. So she's like casting magic in the air by holding her staff up. Now we created all of these animations in a generally generic way. So basically in the demo we have several biped characters. We've got like the knight, we've got the witch, we've got the wolfman, we have a couple of skeletons. And basically we wanted to create these animations in a way that they could all be shared across their different rigs. So it's like if you create a game with 200 characters, you don't want to create 200 individual like run animations. That's like kind of a waste of time, especially for the characters that generally have 2 legs and 2 arms, right? Obviously it doesn't help if you like have a spider, because a spider and a human can't really share like the similar animation data. But in our demo we did. We had a lot of characters with 2 legs. So we created a more generic rig, which all of these characters then inherit and share from. This biped rig, which is arms, legs, and even like slots for like the hands. And this allowed us to basically swap and replace all their different animations between each other. So we got like the generic run, which like basically all the characters use. We also have like a get hit animation, which all the characters use. But also it allows us to do things like give the wolfman's idol to the witch, which looks kind of weird because the wolfman's got like a longer neck, right? So her head is kind of like a little bit more stretched. But that's partly, but notice that I could switch to this Wolfman idle and all the animation data is still like sequencing in the same way. I can switch to like the Wolfman's attack. So he kind of like swings an axe, and she's going to do that with her staff now. So notice that basically all this animation data is just swapping between these similar rigs. Now what's interesting is if I go to like the knight attack, so he kind of like swings for with his right hand, or maybe she's like punching the ground or something like that. What you'll notice if I zoom in is that her face actually changes. So that sprite swap I showed you earlier on with her mouths and things like this, basically her mouth changes. So she's got like an open mouth here, and then when she like swings the sword down, I'll show you, she like actually grits her teeth. So you can actually swap between the different sprites at runtime, in like the animation system and also by code. So you could have like a character like grimacing when they're getting hit or something like this, or like getting more angry when they attack someone. So you can kind of tie in these workflows together, which is pretty cool. As we have all of these elements like shared between all the characters, it also means that we can actually swap out what the characters look like with each other. So this is using that same sprite swapping system. So we have the witch that looks like this with a staff in her hand, but I can then change it to another one of the PSBs which has that like humanoid form. So I can actually change her to the wolf. And look, the wolf is now going to hold the staff in his hand and basically have all the same animations. So this is very powerful and flexible because we can then instantly change between these different characters. So we can like create a skeleton that basically uses the same animation sets as all the other characters and swap them out and test them. So I'm now going to have a look at the knight, the witch, the skeleton, which is another humanoid character we created. And basically you can notice that it's instantly swapping, and that staff that's in the hand of that character is then retaining. So you can be very flexible and dynamic with how your assets and how your content is all set up. It's pretty cool to be able to test all these. So like switch to the skeleton and then have the skeleton doing the Wolfman attack as well. So it's very powerful. I know a lot of people build games with like, not like 5 characters or 6 characters, but they have like hundreds of characters, and they add new packs that come out like DLC and things. So it's gonna be a very nice workflow for people creating new forms. The last thing I want to show about this is we created as well a base character, like a base biped character. He kind of looks like a crash test dummy, but he doesn't really look like he's part of this game. And this is kind of like our like generic in this game, like humanoid form that we basically use to base a lot of the other characters from. So we kind of use this, and then all the other characters inherit their rig from this guy. So if we test the animations all with this guy, so like have him running, things like this. Notice the staff is still like attached to his hand, which is kind of cool. Or we have like the witch idol. He's automatically working with these animations, and we wanted to create a nice workflow where we knew all these animations worked with this base character, and then they'd work with the other characters that are inherited from his rig. It also means that, let's say we wanted to create like a new character, like a goblin, like a goblin boss that you can fight that was also a biped, then we would basically take this base character and then base the goblin off of it. So we know that all the run animations and things like this for the other characters will work with that goblin. So it's a really nice way of having this base unit and then building off of it, basically. What's even cool is you can also sprite swap him as well, so we can actually have him like, you know, like winking. He looks worried now. Okay, now he's winking as well. So yeah, so that's basically a summary of our like character animation here. So now what I'm going to do is I'm going to go back to the battle. So our characters now also create like spells or abilities that they then cast on their targets. And obviously when you do like a spell in a game like this, it's not just a character, you know, waving a sword around. You also have many other elements such as like audio playing, or maybe like VFX appears, or you triggering off code at some point in the sequence. So we used a tool called Timeline to basically do all of this work. So if I get the timeline tool and I select the witch special attack. Okay, so that's basically the witch attack, and you probably heard that as well. Sorry for headphone users if it was too loud. But what you'll notice on the timeline is there's lots of different tracks and lots of different elements for different parts of this ability. So this witch attack clip at the top was that like witch animation where she like holds her staff in the air. That's just that clip there. Whereas we have lots of other clips for VFX, for particles, for like audio, for even 2D lights and things like this. So now if I play this clip, so she creates this big ripple, this energy ball, and then if I now scrub through and show you, so she creates the particles, they move along on this path, and you get the dragon, and then they create this ripple effect throughout the scene. So this ripple effect is actually just a giant 2D light that I scale across the scene, but then I cranked up the Fresnel. So basically you get this really cool like ripply glow effect around the edges of the characters, like heavily inspired from, I think, an episode of Star Trek or something. So you got this pretty cool ripple effect that goes through like all these Fresnel maps. So you can combine all these different things together, like timeline with an animation, with particles, with 2D lights, to create some really nice results. And this is actually my favorite effect, like in the project, like this cool ripple thing. But basically, kind of the point I want to make is that workflow I've shown up to now, including that little animation of the witch attack, that then gets built upon for like this ability. So everything is kind of like making sure that the pipeline is really nice with the 2D tools to get to this point where we then integrate it into the actual game. One last point with timeline is we use this tool. It's not specifically 2D related, but I think it's pretty related to sequencing with animation, called signals. So what signals on timeline allow you to do is actually trigger off like functions and code in your game at a certain point in time. So this is pretty handy for stuff like QuickTime events or cutscenes. But in this case, we have like an attack. So I play it, and we basically want at this point when the explosion happens for the enemy units to like take damage and stuff like this. So by adding this little timeline signal, we're able to easily like be flexible, because then we can position this to a new point. Like maybe I want at this point damage to apply. I can then just drag this timeline signal to that point. I didn't have to change a line of the code. I didn't even have to think about code. And basically it automatically is like hooked up the code to that specific point in time. So timing is pretty powerful if you want to hook in gameplay and not have to like rely on artists asking programmers, hey, could you delay the unit taking damage by half a second, or programmers saying, okay, I have to constantly like babysit the animators to make sure this value is changed. So it's basically like an event. That's just an added bonus here. So that's pretty much a summary of timeline. I know we're coming towards the end of the webinar, but hopefully this has been useful so far in showing the pipeline all the way from Photoshop through to the rig, through to IK, to sprite swap, to lighting. It was kind of touching on lots of areas in very small detail. So hopefully it was useful to learn lots of different little parts of this character art pipeline we used on this project. And it obviously gives you areas for you to then dive into, like IK or other different areas of this pipeline. I know I'm repeating myself right now. The last thing I want to show you is actually the dragon. So the dragon's really cool because it doesn't use biped. It's not like a biped character. It doesn't have 2 legs and 2 arms and a head. It's got like a head, obviously, but it's got like 2 wings, 4 legs, and a tail. And the workflow I just showed you for setting up the rig for the witch and like the IK and the animation and things was basically the same workflow for the dragon here. Like you can see the same bones, you can see the same like IK points. So Jarek set up an IK point so we can actually like animate the dragon like biting and things like this. We can animate the bones so we could have the dragon talk, or we can even make the dragon like asleep if we wanted to. Things like this. Bend the wings back. And we even have tiny little IK legs for like these stumpy parts here. So basically the dragon followed the same process and workflow, but obviously for a very different form. I can even select the dragon and show you what it looks like directly in the sprite editor. So if I open up the dragon sprite editor, noticed it's also a Photoshop file and it's also split up all the layers automatically. If I switch to the skinning editor, look, it's also using a rig, and it's also got all these different parts and all these weights. So the point I want to make with this is, with the Dragon, we wanted to add a non-biped character to show that all these workflows not only work for like characters with like 2 arms and 2 legs, but they work for pretty much anything. It works for this crazy dragon. I want to try it on like trees, so have like trees like swaying in the wind, or like characters' hair and things. You can rig sprites in Unity and then get some really nice, interesting effects with them on the other side. So hopefully you'll be able to reference this project when you're using these workflows. No matter if you're doing 2-legged characters, if you're doing dragons or trees or whatever it may be. Obviously, I can then also show you the dragon's mask maps, normal textures, and things like this. So yeah, that's pretty much the end of my my demo. I'm now going to switch back to my slides. So that was the Dragon Crashers project. Everything I showed you is in 2020.2.7 and is the version from the asset store. So everything I showed you can do right now. You can literally watch this video back and do all the steps I did one by one. You could obviously also dissect it. So you could like open up the project and look at particles and look at shader graph, or look at all these other areas that I didn't talk about, and learn from other different areas of this vertical slice. I want to say a massive thank you to Mindsjar Design, Yarek. I know he was in the chat and I think he was answering some questions. He was the art director, artist, animator, VFX. He basically did a lot of painting, rigging, all these different things. I've worked with a lot of artists over the last 10 plus years, and he's by far one of the fastest I've ever worked with. Amazing guy. If you're ever looking out for like working with someone or contracting someone, definitely reach out to him, Mindjar Design. He's an awesome guy. And I want to say thank you, and cut to Q&A. So there's some, well, before with Q&A, there's some more information here at these links. We have this Dragon Crashers link in the middle, and it's downloadable from the asset store and compatible from 2020.2.7 and up. We're going to be looking into moving it to like 2020 LTS and things like this in the near future. And we also have a blog post, which I will now jump to now, just to let you know. Obviously, you can now pause the video and type this out, but I just want to show you to this blog post that we put together. Well, that's obviously the asset store page, not the blog post. So here we've got this blog post here, and if I scroll down, so we got a lot more information about the project. So we obviously have a lot of things that we spoke about, like the rigging process and sprite swap and things like this. But the blog post also covers a couple of different things like tile maps. It covers like sprite shapes. So we use sprite shape a lot for like the roller coasters in the background and various other elements. We also have pretty much all the assets in the project have like normal maps and mask maps and things like this. So even if you're not doing characters, but you want to know like how the crystals and rocks were set up, you can dig through the project. Like I spent a long time going through and trying to tidy everything into like these art folders. So we have all the environment, you can grab all these rocks, you can grab all the lava, the ladders, you can look at all the normal maps and mask maps for all these different elements in the project and see how they were put together. Particles, we got a lot of stuff in this blog post, even down to gameplay architecture, which I put in at the end because I know a lot of people want to see the pretty visuals first before the code, which basically goes how we made it in this project in a generally modular way. So we could test different parts of the project and work on different parts of the project without stepping on each other's toes. So this might be useful even if you're not making a 2D game. And yeah, that's pretty much it. I mean, we have some forum posts. I mean, I'll show up the links at the end. We've got a forum thread, which can be accessible from like these links. And we also have the blog post as well, which you can then comment on. And if there's anything like I haven't covered, but you're perhaps interested in us covering in a future webinar, definitely leave comments there on the forum thread or in the survey. Fill that in because it'll be great detail to us. And then we can do more webinars in the future, whether on this project or similar stuff. I'm obviously on Twitter as well, where I just share a lot of information, knowledge about Unity. And now I'm going to jump over to the Q&A and I'll see if there's any questions for the next couple of minutes. Let's have a look. Okay, so there's a lot of comments in the chat. One sec. Let me just get set up. Okay, so Q&A. So there's 14 questions. I might not have time to answer all of them, but anything, wow, 73 questions have been answered by our team, which is actually pretty amazing. So thank you for doing that. So I'm going to look at the Q&A questions and see what I can answer that I know. So the first question, in my project, the Shadowcaster is casting shadows on my default layer, when it should only cast its shadows on the background layer. I have my characters all set to default layer using sorting groups. Is this a known bug? I might have to see some screenshots for that. So post it on the forums and then link it to me on Twitter or somewhere, and then I'll have a look. I might have to dig into that. Let's have a look. I'd like to learn all there is about shader and normal maps. How do I get the resource? So you can download this project and have a look at how we put together these things. We also have opportunity to do more webinars like this, specifically on Shadergraph, which I'd be more than happy to do, and normal maps. And I think Yarek or Mindjar Design is going to work on a blog post about like the actual creation and painting process. So hopefully that is in the pipeline. Another question. So if you want to do an animation like the witch throwing a fireball, but with a dynamic target, how would you do it? That's actually a pretty good question. So probably one way that you could do it is you could have a transform associated with a witch, which is like target, like fireball target or something like this. And then you could use a tween library or some like LERP code. So basically move the fireball to that dynamic target. And then when the witch like throws a fireball, just as when you like choose where to throw the fireball to, you could like teleport the transform to like that target and then tween the fireball to that target. At least that's how I've done it like many times in the past, even back in like Flash days. So that's probably how I'd do it. In this project, it's pretty static. It's kind of like Final Fantasy, where they always like spawn spells to like roughly where like the enemies are, like a fixed point. But I would be interested in adding some more dynamic elements like this. Someone said in the chat, I have a love-hate relationship with tweens, which is an interesting comment to make. I mean, if you use do tween, it makes everything like 10 times easier. So yeah. Let's see what other questions you have. Using Shadergraph. So we use Shadergraph for some of the effects. We use Shadergraph for like the lava in the background to make it flow. So there's like a flow graph shader. For a lot of the elements like characters and stuff, they actually use the built-in shaders. So if I actually switch back to Unity, so a lot of things like the tile map, I think the coins, the characters for sure, the rocks, basically pretty much most things in the project actually use built-in shaders, like no custom shaders and no Shadergraph and things like this. We actually used Shadergraph to create the lava flowing in the background. I think that was the very first thing I worked on the project, just to see if it was possible. So basically it's a Shadergraph to do things like flow graph effects. I'm probably breaking this right now so you can have lava flowing quicker and things like this. I think we also use custom shaders for the particles to make them glow a little bit more. We're using post-processing, but yeah. So you use some custom shaders for things. And I definitely think there's a lot of weight in a future webinar on Dragon Crashers and all the different little shader things, because we mostly use them for like, not the main gameplay, but all the environment stuff. And I think there's an interesting like conversation around that. Yeah, I'll obviously cut back to the slides. Let's see what other questions. So I noticed in the chat, a couple of people said that the mouse cursor was lagging a bit behind in the recording. I think that's partly a Zoom issue, but I know that we're recording on the cloud and with Zoom, and I'm recording locally as well. So the end recording will actually be like in sync. So either it will be my local one or the cloud one. I'll have to evaluate the end audio video recordings and see if the quality is good enough. And if the recording is not good enough, I'll just re-record the whole webinar again. So like either way, this recording is going to come out at some point very soon with basically exactly the same steps and stuff. I've only had to re-record a webinar twice before, but like I'd rather the quality was great and the audio was great than it being slightly out of sync. Where can we find the recording? So obviously the webinar is still live right now and still recording right now, but the recording will eventually end up on YouTube. So it'll be like a YouTube link, and we'll obviously share the link and send you emails and put it in the forums, and I'll get some skywriting from a plane, you know, all the stuff that we usually use for marketing. Let's have a look. I mean, there's 80 answered questions, which is crazy. I'm going to have to go through this. So I want to say a huge thank you to everyone from Unity that's currently in this webinar, who's been helping out, watching, learning. I mean, they built all these tools. Like the people who built all these tools are in this webinar right now. So give them a huge thank you, either here or on the forums, because they build all this amazing stuff. And they're in Singapore, so I think it's currently very late for them, or very early. I'm not too sure. But they're an amazing team to work with. 2D Team's probably my favorite R&D team at Unity to work with, so it's super awesome working with amazing people. We have Eduardo, who's obviously the project lead on the project, and he's been helping out with a lot of questions and things. We've got Ted from the 2D team. We have Yarrick, who are Mindjar Design. Thomas Richards from the community team. He's an awesome guy. Both Russ and Paul. So yes, that's pretty much the end of the webinar. I know we've gone over a little bit, and I apologize. So if it's early in the morning, I guess you're starting your day. If it's 1 a.m., I guess you're going to bed. And for me, I'm going to go start preparing dinner. So thank you all for joining. It's been a lot of fun watching this, and I hope you learned a lot in this process. And let's keep in touch. If you have feedback and use these tools, if you download the project, let us know and talk to us. We're here to chat and here to have conversations and things. And if your questions weren't answered, I apologize. We're going to get all the answers and questions, and I'll probably end up like posting them to the forums and stuff like that. And that's pretty much the end of the presentation. Thank you for everything, and I will see you in a future webinar, or hopefully at a future event when we all are vaccinated and we can talk about 2D in person. But yeah, thank you.